My name is Megan, and I will be taking you through the Speedy Shelter Engineering Challenge. I'm a recent graduate from WPI with my bachelor's in robotics and mechanical engineering, and I'm an incoming mechanical design engineer 1 at Medtronic. If you're doing those activities, you've probably heard a little bit about engineers already, and you may even know some things about what different projects engineers may work on. But do you know exactly what an engineer is? This question's a little tricky. There are a lot of definitions of engineers because what engineers do vary widely. Here is just one definition. Engineers as practitioners of engineering are professionals who invent, design, analyze, build, and test machines, complex systems, structures, gadgets, and materials to fulfill functional objectives and requirements while considering the limitations imposed by practicality, regulation, safety, and cost. That's a mouthful, and it's a very broad category. That's because what engineers do is very broad, and there's a lot of different categories of engineers. I think this quote sums it up better. As engineers, we are going to be in the position to change the world, not just study it. Engineers have the ability to use the problem-solving skills that they learn throughout their education in order to make products that are able to change the world. It's a lot of problem solving, but I think it's very rewarding. In this activity, you're going to get to try some of it. We'll be looking at this particular mission scenario. First, I'm going to read this hypothetical mission scenario, and then you'll get a chance to enact it as though you were these cadets. Ivy, Bianca, and Chloe, the resourceful cadets, were separated from their troop after an earthquake. It's getting dark, and the girls decide they must quickly make a shelter to spend the night. Abby, an aspiring engineer, suggests the team use the engineering design cycle to make a shelter. You can see the engineering design cycle here. The first thing you have to do is identify a problem. Then you can brainstorm solutions and focus in on one or two designs and flesh them out. Then it's time to build a prototype, which you'll then test and evaluate, which will probably lead to more redesign. Once you're satisfied with your solution, a good engineer knows how to share and present that solution. The girls were able to find these things in order to help them make their shelter. Cardboard, specifically corrugated cardboard, so like the type of cardboard that you would use to send a package to a friend. 3-foot-long bamboo stakes, trash bags, scissors, duct tape, and string. Their shelter must be able to hold, this shelter must be able to stand without a Girl Scout holding it. It needs to protect them from the incoming rain and the high wind speeds, and it should be able to comfortably fit 3 cadets. So they were able to make their shelter, but we don't really know what it looks like. So it's your turn to brainstorm what it could have looked like. Before you get started, here are some important safety notes. When buying the stakes for this challenge, you should buy bamboo or other natural material stakes. Fiberglass stakes can bend back and if you're not holding it and cause serious injury. You're also, before getting started, you're going to want to cut the trash bags into flat sheets prior to starting. This will help ensure that no one gets hurt in the process. Here is your time to brainstorm and design. We recommend doing this challenge in groups of 3 to 5 because good engineers know how to work together, but if the groups are too big, it'll be hard for everyone to participate. You're going to use pen and paper to draw up multiple possible solutions. It's important to remember that there are no bad ideas. And sometimes it can be fun to come up with ridiculous ideas because it can help get your creative juices flowing and help you stumble upon ideas that you think are better. Also, make sure to listen to everyone's in the group's idea. Once you're done brainstorming, you're going to want to narrow down your ideas to one. Pause this video now while you do your brainstorm and design. Now that you're done doing your brainstorm and design, you should have an outside volunteer look at your project. In engineering, design reviews are really important because it can help us catch problems before we go on to the build state. As with anything, it's always nice to have an outside pair of eyes look at it. Pause this video now while you get a volunteer to look at your design. Now it's time to build and test. You'll use the materials previously stated in order to create your prototype. Here are some problems that you may come along. Connecting the parts together is really hard, so you want to make sure that your joints are very strong and flexible, and the easiest way to do that is with the duct tape. You may discover that your frame tilts or twists. One way to strengthen the frame is to connect each piece to one or more parts. And if your frame wobbles, in order to increase stability, you're going to want to anchor the frame to the floor with tape or secure it by running lengths of string from the frame to the floor and taping them down. Pause this video now while you build and test. Once you're happy with your design, you're going to want to present it. A good engineer has to be able to present their designs and convince others that their design is worth investing in. You can practice your presentation skills by telling your troop, family, or friends why Abby, Bianca, and Chloe should go with your tent design. Once you're done presenting, we'll do a little wrap-up. Here are some wrap-up questions we recommend groups go over. How did your final design differ from your original? Many people showed the design process to be circular instead of linear. Why do you think this is? What forces affected your shelter the most? What tent shape seemed to be the strongest? What were some successful strategies for making your shelter more stable? And what design changes would you make your shelter easier to use or more useful in an emergency? Pause this video now while you go over these wrap-up questions. Some other things you may want to consider. This exercise focused on one specific incident from a temporary shelter that may need to be created, but there's other reasons people may need a temporary shelter. Some examples may include after a natural disaster, if they're experiencing homelessness, or just going on a camping trip. Why else might someone need a temporary shelter? Well, this example was hypothetical. There are many real-world projects focused on this, on creating tents and other emergency prep. We'll now watch two amazing women, or videos of amazing women doing just that.
This is Connie. She's a design engineer.
I'm a design engineer at Nemo Equipment. Nemo is a young company. We're based in New Hampshire, and we make tents. I knew I wanted to do something in science and engineering. I also wanted to keep playing sports. The school I went to helped me do both. A lot of people that I played sports with, especially on my basketball team, were doing really cool things, and they had to do with sports engineering. And I was thinking, wow, that's what I want to do. How do I do that? I really, really want to do this. I have to pursue this because it took what I was passionate about and combined it with what I was good at. That's something I could contribute to. This is a Morpho AR. It's an air beam tent. This is the Nemo air beam. Let me pump this up a little bit. The air beams are the support structures for the tent. So in place of poles, my job is to make sure that they can perform up to spec. I could hear the air in there fully expanding this air beam. So right now it's at about 7 psi, which is the operating pressure. You wouldn't think that's filled with air. We do a lot of testing. So this is our rain chamber tester. Don't be deceived by its looks. It's actually very high tech. It uses lawn sprinklers.
In a virtual rainstorm.
You can really see what happens when you take your products to the limits, and that's really what we're trying to do here.
If there's a problem, you can see it right away, because you'll get really, really wet. It looks good to go.
This is not the usual way we transport our tents when we're camping. This is our version of a wind tunnel. This gives us a controlled way to increase the speed. We can incrementally increase that wind speed.
Looking for 25?
Yep, 25. The performance of a tent is dependent on a lot of factors, and its ability to withstand wind is a really important one. Let's go to 30.
Got it.
It's a good thing that we're not seeing much movement. 35.
Cool.
All that noise was generated from the strapping,
But the rest of the tent is dead static.
Try 50.
Works for me.
The tent's just barely feeling the effects of the wind. That's 55 miles an hour.
everything is totally stationary. It's whatever you're passionate in. It can be anything. Everything that is around you has been engineered by somebody. You have so many possibilities to have a hand in something to make a difference, and engineering is a great way to do it.
Our next video will be focusing on Luminade.
Anna and I started Luminade because we believe light makes a difference. We were inspired to invent the Luminade light while we were graduate students in architecture school. It was 2 weeks after the 2010 earthquake in Haiti. We were looking at what was being distributed, and we saw that they were distributing medical supplies and shelters and other types of supplies, but there really wasn't a lighting product that was being shipped in volume. And we saw that a lightweight, portable light that was rechargeable could really add a lot of safety and comfort to those victims. Typically after disasters, the lights go out. And the alternatives are something like flashlights, which require batteries, and oftentimes people in certain parts of the world have to use kerosene lanterns or candles, which are dangerous and are fire hazards. Portable solar lighting, like our Luminade lights, provide a clean and safe alternative to that. The Luminade light is a compact, solar rechargeable lantern that packs really small and weighs just a few ounces. There's a solar panel, rechargeable battery, and it inflates to diffuse the light and reduce the glare on your eyes. So if you press the button, it provides over 30 hours of light, and then you just recharge it in the sun. It's totally waterproof, and it's made of a really durable and weather-resistant material. We sell our lights all over the world, online and in camping stores. Boaters, outdoor recreationalists, hikers, campers, they love our lights because they're super lightweight, they're durable, they're easy to charge, compact to carry, and environmentally friendly. Since that first light, we've grown our company and reached tens of thousands of families across the globe. But we're still just a small group of dedicated people, passionate about working together to empower people with light. Besides our partnerships with NGOs such as UNFPA, Shelterbox, and Doctors Without Borders, we are also passionate about other ways to give back. So we designed the Give Light, Get Light program, which allows Luminade supporters to help us make light accessible to all. Participants receive one Luminade light for themselves and sponsor a light to a family in need. We've sent more than 20,000 lights to families in more than 50 countries across the globe. We believe that a little light can have a huge impact. Luminade is proud to help brighten lives around the world.
We hope you were inspired by the activities that you did today and what you were able to see. And we hope that this piques your interest in engineering.